session on observing and optimizing interaction to next paint at scale. And we have a little bit of a round table, as it were, so hopefully we can have some interaction besides. So, as you know, hosted at DDM and with the help of Sergey and the New York UX Speed and Web Performance Group Meetup. As for our team, listed on the slide here is all of us. I'm Ty, and software engineer on the speed team at DDM. Joseph's on the left here. He's our principal engineer, and Russ is our manager. Hal, who'll be speaking via Zoom, is one of our QA software developers, and he'll speak a little later. I'll pass the mic on to Russ and then to Joseph, and then to Hal. You don't know who we are. We're America's largest print and digital publisher. You might have heard of some of our brands: People, Investopedia, Birdie, Health, All Recipes, and many, many others besides. These are our core values. So far as tech and other things go. We want the best content, the fewest ads, and, for our purposes, the fastest sites. It's one of our core values. We care a lot about speed. And today we're going to be speaking about an important aspect of speed, INP. Okay? What is the screecher? What is INP? How do we observe it? How do we optimize it? And how do we test it? I'm going to be presenting just some of the background, which some of you who are attending a speed meeting might know a little bit about, but if not, if this is totally new to you, here goes. INP stands for Interaction to Next Paint. Okay? Good INP score, less than 200 milliseconds. Iffy INP score, over 500 milliseconds to 5 million milliseconds. Try not to be in that realm. Everything in between is orange, yes. So, some background. We have Web Vitals, and we have core Web Vitals. Web Vitals measure their metrics, measuring user experience on a page, including such creatures as first contentful paint, time to interactive, total blocking time, speed index, and others. Maybe you've heard of these terms before. Some of these metrics are core Web Vitals. They are SEO, rank and SEO effective. Right? And if we consider the three aspects of user experience, performance on a page, you've got loading, which has this core Web Vital of largest contentful paint, right? We've got visual stability. We care about how elements on the page are keeping in place or jumping around. Cumulative layout shift. And then finally there is what we're going to be speaking about today, interactivity. How do we measure that? And first things first. How do we measure that? How did we measure that? Let's speak about first input delay, which INP kind of replaces as a core Web Vital. Okay, it's still, oh no, what happened? Okay, there was an input delay. Okay. So first input delay measures the user's first impression of interactivity on your page. Okay. It's the time between the user first interacting, clicking, doing something, some event, fires off, okay, and the time the browser is able to respond to that interaction, the delta between the click and the main thread being idle again. Something like that, right? Or not, so maybe it's new to you. And what's the rationale for this? Well, first impressions last. Okay, first impressions matter. It gives the user a sense of what else is going to be happening on their page and how their experience is going to go henceforth. Also, early on, there's a lot of loading on the page, a lot of things happening on the background, and it's problem points, right? Often the worst kind of interactivity problems happen at this point. So if you can fix it, if you can optimize first input delay, maybe you're in a good position, for the rest of the time that the user's on page. This was our core web vital for interactivity. Now, there's a new kid on the block. Okay, interaction to next page. And this measures more broadly the overall responsiveness to interactions on the page. Okay. In particular, it measures the longest duration from an interaction to the browser's painting of the next frame. Okay, so we kind of move from first to worst. And you can see a difference over here. Here's the input, click, idle, okay, things continue. This little region in red is where our first input delay is. And over here might be where our that big red circle is what INP is measuring. What's the rationale? Well, we have a broader perspective now. We have a more complete picture of the interactivity throughout the life cycle of the page. There's a benefit to this. A little table summarizing most of what I said. First input delay, interaction to next page. Okay. Here you can see the difference too in what makes for a good first input delay versus a good interaction to next page. The numbers are a little different. Another thing, I'm going to hand over to Russ and Joseph to expand on this. First input delay is easier to measure, to diagnose problems when they arise. Interaction to next page presents some new challenges. Okay? And, well, let me pass over as promised to Russ and Joseph to expand on that.
Thanks so much, Ty. All right. In a lot of performance work, it's really common for us to just start throwing like little tips and tricks out, let's just swap, inner text with text content. We know that'll be great. Well, but do we really? At the scale with which we operate, observation is key because particularly when you're working with search is very important to us, as is ad revenue. 100 milliseconds can add up very, very quickly in terms of impact. So we have to be very, very careful with these decisions. So for some of you that might not be as much of a concern, but for us it's a big part of our work. And that's really getting a sense of like what is the issue that you're trying to solve going in, what is your current stats on that, once you release, so there's a lot of steps here. So my motto used to be go chasing waterfalls. And I was like, don't listen to TLC. Waterfalls are great. That's like the backbone of the performance community, particularly with web page test. But this is changing as I do a lot of advocacy around the company, and we do as a team. The previous workflow I recommended, I presented this last year, is particularly if you're doing incident response, that you're somehow aware of an incident, that you look at your dashboards and start kind of ruling things out so you get a sense of what the issues are and are not. Like for example, if you're seeing LCP drop, try to rule out the server right away, right? Because that's a whole world that, if that's not a problem, all those stats are great, then you can rule that out, and then you already know what you're more where you should be looking. And so that kind of helps form a hypothesis, right? Like if my LCP is tanking, I'm probably already going to suspect there's something wrong with our images. But then from there, I would go looking at waterfalls. I would go to see how things are loading, what the hang-up is, and half the time it's like a DNS issue or some sort of handshake problem, right? So that would look like this. We have an issue on one of our templates. I can see that it spiked quite a bit on LCP, and then I would go identify that in the waterfall. So for interactivity, with FID, we didn't need this how I put it. FID was just not so much of something we had to worry about, but INP is something new. And I think there's a lot in the industry, from what I'm seeing from stats, that a lot of folks are having to figure out, how do we think this way? And I think that, shout out to Annie and Chrome team for putting together this metric. It's a great metric, especially as customers get rid of maybe mobile apps or desktop computers. They're mobile first, right? So mobile is slower, so we have to make sure interactions are better. And then on top of that, and then some people can turn like your app into your web app into a mobile app, right? Like that's a newer feature, and Chrome team's also pushing progressive web apps. So interactivity, people are going to expect the same interactivity from a web application that they would from a mobile app. So that's a little bit of a challenge because they're not really the same. So. And from, before I get into kind of how we tackle it, right, so we all have Google Search Console. If you haven't opened up your account to claim your stats, go ahead and do that. Here you can see I'm showing our mobile and desktop, and I picked a brand that is perfect. So as far as for interaction to next page, I think up until January, Google was letting you know what interaction on a particular page was a problem. And then they took that, they got rid of that. Does anyone remember that? Did anyone use that? Oh, okay, so it was pretty handy, right? You look at the URL and it was like, this is the offending element. And so now we do not have that information available in Google Search Console. So we just kind of have a general idea of what URLs might need some improvement. And of course that's based on the Crux API. This is a screenshot of the public Crux dashboard that you can go to if you've never looked at it. It's really great. This information, in case you don't know, so the Chrome team measures all of your interactions. Well, not all of them, it's anonymized and privatized and all that. But they're recording that information. And then they are scoring kind of, looking at the performance metrics for those pages. Then they hand that information off to SEO. So that's kind of how that works, and then SEO decides what to do with those metrics. So in this case, we have our 3 core web vitals, and here we have some information about how interaction to next pane is doing. But again, we're not getting attribution information. So if we think about an event, we have like a click or thumb down, a key event. We want to know what element, when it happened in the page session. There's a lot of things we want to know that we have to find a way to get. So enter, I think, the age of the performance tab. If you weren't using this already, I strongly suggest it now. I'm recommending it in training across the company for folks to be able to use this. Often web perf stats and performance optimization is seen as kind of, I find, like a more senior level experience, skill level. But I think in particular as frameworks become optimized and maybe even AI starts to develop them, I think understanding the platform is really, really key. And this tool is just a really fantastic way to do it. You might be familiar with Lighthouse or the Performance Insights tab. I really love this one because it really allows us to drill down and understand exactly what's happening. And then you can take a nice screenshot, you can download a trace file. So going over what we have here, we have at the top our flame graph with highlighted in red or long-running tasks, right? So those are things that are taking too long on the main thread. Below that is a film strip. And then below that we can see all the network calls, first paint, first contentful paint, those key page load metrics. There's interactions as well, and then we can see our main thread. So this is really where we start to pick apart interaction to next paint, and this is really where you can see the smoking gun, so to speak. So this tool is very, very powerful, and most developers should be developing mobile first anyway, so it's very easy to have this open, start a recording, start a screen recording, and boom, you've got your evidence about what's happening. So that's really important. Lighthouse is great, but as far as an automation perspective, interactions can't be measured, by Lighthouse off the bat. Like you'd have to enable Playwright or Puppeteer or something to be able to create interactions while Lighthouse is measuring. And that, for any given page, can sometimes have hundreds of interactions at any given time, right? Like an interaction on page load is different than an interaction towards the end of the session. So Lighthouse is great. I mean, if some of you all are using other tools that I don't know about, please do share. And then we also developed an in-house tool. So we use Catchpoint. Catchpoint right now is capturing interaction to next paint. They're using the Google Core Web Vital library, which is really a great tool to use to capture these measurements. And there's a plugin, which is really great. But it can also capture attribution information. So that information about like class names, what the score was, when it happened, all those things. So with Catchpoint, should be releasing that hopefully in July. So we've been encouraging them, and it's exciting. So we'll have that. I don't know if SpeedCurve does, if they're offering kind of INP attribution stuff. But yeah, so if you have the latest, greatest information, let us know. Share the room. And then, so here we, our fantastic infrastructure team put together a dashboard with Elastic Observability where we are using that library. And so here we're getting class name, element, event, the measurement, the score, and the URL. So this is really great for our non-production environments. Yeah, so that's pretty much a quick overview of how to observe it. But I find overall advocacy is a big thing here, because I feel like it's a shift for developers, and I'm not quite hearing out there in the industry as much people talking about kind of what's really needed to solve these problems. But I don't know, maybe some people were already crushing it. So, but in any case, Joseph will speak about how we can improve INP.
Thanks, Russ. Hello, everybody. So you got the history of Core Web Vitals. You now know how to measure Core Web Vitals. Now what do you do? I think maybe that's why everybody's here. All right, so the first thing is, well, we're going to talk about INP at scale. When you have a large organization, you have many teams, we have tons of brands, how do we optimize this at scale? So the first thing is the organization. You need to have organizational buy-in. That means internal advocacy. You need to educate and train what is INP, how to measure it, which Russ talked about, all these things. Monitoring is important to know what's wrong. And also, in large organizations, you have to work with your vendors, because your vendors could be offending your page and you have no control over that. So have a good relationship with your vendors as well internally. So, optimizing for INP. You have to think of this more strategically rather than a bullet that this is the silver bullet that's going to fix everything. Because INP is not like that. And the key is INP, interaction to next paint. Modifying or optimizing for that paint, because that's the key. That's what gets measured. So I've divided into two sort of groups. The first one is the idea of asynchronicity. This came from the Google folks when they were introducing INP, and they gave a whole presentation on how to optimize for it. And they talked about asynchronicity, where everything is sort of asynchronous. Rather than reacting immediately to those events, you need to do it asynchronously. Wait, let it fire later. Clearly in the browser, there's many options to do that. We have promises, async await, set timeouts, schedule a yield, etc. And there's many ways to introduce asynchronicity to your events, your callbacks, and other things. And the second part I want to touch is when we started rolling out our optimizations, we realized you have to rethink all your classical optimizations that you made. When we first bundled everything together and minified it, and it's the first asset that comes on your page. Maybe that's not the greatest idea, because now you're downloading a 0.5 megabyte JavaScript file that has to parse that. First it has to download it, it's got to parse it, and then execute it. The bigger it is, the longer it takes. Maybe divide that file or chop it up into different parts. So you have to rethink the classic optimizations that you were originally running on your page. And also you would also maybe defer everything until later. Now that you're deferring 80% of your execution to later, that can cause an INP, because at that point, when you're running that 80% of the code, the user's interacting with your page. That can cause a problem. So you want to think about how can you break down your libraries into sort of discrete parts where you're chopping them up. So it allows for the browser to pause and then react to an interaction. And also I want to focus on something that's not really talked about, where you can divide the UI, or the user interface components, what happens in the front end, versus the background stuff that happens in the background. When you're fetching data, you don't have to run the main thread, maybe use web workers or other optimizations that are available in the browser. So internally, we create a set of tools that take those ideas and allows a developer to just leverage these utilities, and they don't have to think about, is it set timeout? Is it request animation frame? Is it a schedule thing? So we've created internally sort of a set of tools that allows a developer to not really think about all the different details and the callbacks, different things. They sort of wrap it. This is just an example. It's not real code, but the idea is that you have your callback, and we sort of wrap it in this tool, and now asynchronicity source built in, and that takes care of that. It doesn't take care of it completely, because you still have to optimize that callback. If that callback takes 500 milliseconds in itself, you probably want to split it up into other parts. But that's the general idea of sort of internally how we sort of approached it, right? We educate, like, hey, this callback might take a while. Maybe wrap it in this utility. And you can apply this to callbacks and events, and these are things you can do proactively. So here's just an example of some improvements that using this kind of strategy. So on the left you have the before. This is every link on your page should be tracked, right? Know where you're going, what's happening. So this is the code or a snapshot of what happens during when a link is clicked. So you can see here it took about 32 milliseconds for the reaction to happen. After applying some of the strategies, we brought it down to 13 milliseconds. That's a 60% increase in performance. So that would help. And as you can see, what we did was take that blue area, the event, and make it asynchronous. We pulled it out of the, and you can see on the top line, that pointer is much quicker. So that's just an example of ways to optimize your code. Yes, so that's our the overall. Now we're going to turn over to.
Now we have Hao from our QA team just speaking about how these events change. All right. Hi, Hao. How are you doing? All right. Please take it away.
Yeah, hello everyone. I'm the automation QA engineer in Speed team, and I would like to talk about the transforming the testing strategies to support INP optimization. Okay, next page. With INP optimization, the click tracking events are optimized to execute asynchronously, and it improves the page performance and user experience. However, this will introduce challenges in automation testing, which traditionally expect synchronous executions. So previously, the automation test would verify the data from a click tracking event immediately after a click. But with async, such immediate assertions can lead to test failures. Next page, please. For example, expected event is not found. So to adapt this, implementing the waiting mechanisms and the delays can ensure that all the related operations complete before any assertions are made. And another issue we found is the rapid page transitions, such as those occurring during the navigation from one page to another. So during this fast navigation between pages, tests may break if they try to locate or interact with elements that are not yet loaded or have been unloaded. So by monitoring the network requests and tracking the page state, tests can verify that all the required elements are fully available, as well as the data, before proceeding with any further steps. So by integrating these test strategies, automation tests can become more reliable and less likely to produce false negatives. Thanks.
Thank you very much, Hao. So now we'll, thank you. So we went through things I think, fairly quickly, because I had no idea what would be of interest to you. So we did a little snippet, so now we have some time to go into things. What was funny, just to kick us off, when I was hearing you speak, Joseph, I was thinking how, obviously a page load then, that is a user interaction, and it's kind of funny, like the waterfall model is kind of persisting, it's just now we're attaching it to every interaction, right? Which is like...
Waterfalls all the time.
Yeah, it's just kind of wild, so yeah, but it's good. So anyway, yeah, let's maybe we can take a few questions and then see where we're headed.
Yeah.
Yeah, okay.
We
Okay.
Oh, not really a question, but you mentioned sharing tools that you didn't mention during your part of the talk. And yeah, the tools I used are Datadog, RUM, and Full Story. Good experience with those. So,
Okay.
yeah, that's all.
One more time, can you say that slowly?
Oh, you mentioned that I should
What
share.
tools are you using?
Yeah, or have used in the past. And one is Datadog RUM, and
Oh,
yeah,
Datadog.
yeah, and
What
very
are they
similar.
capturing in INP?
Oh, I'm not that well versed in the terminology, but I've troubleshot a problem that's very similar to what you're showing, and it pointed out that it was the main JavaScript thread that was causing the interaction delay, like clicking a drop-down menu and it appearing up like 1.5 seconds later. And the biggest component of that was the main JavaScript thread. So I'm not sure if it's exactly what that terminology, but yeah, it's very similar.
Yeah, thanks.
Cool.
Yeah, did you have a question? Yeah.
I think it's a question to all of y'all. So let's say you were able to optimize the page by 30% from 400 to 250 milliseconds per whatnot. How do you convert that amount into the dollars?
Well, first of all, 250 is not good enough. So the first immediate value is your ranking. So I am not from the Google search team, so but I can say generally what they say is a good core of vital will mean that page gets a boost. If you have needs improvement or poor, no boost. They might be weighing that with other factors, I don't know. So that's the first one, right? So if you're search driven, that's very important. I mean, AI is obviously eating up search a bit, but people will still be using Google for a long time to come, I'm sure. So that's the first, and then we were talking about this today.
So how do you convert it into dollar? I think you want to have the best experience possible. To put an exact dollar amount is hard, but I would say always be improving, and yeah, I think that's all that we can say at this point.
Yes.
Yeah.
Okay, great.
Yeah, so if search is your main thing, you want to be searchable. Also, the interaction with your page, you want to be as smooth as possible. So you said 500 milliseconds? So back in the day when you had jank, right, when things were jumping around, so you wanted to have your interactions with under 50 milliseconds. That gives a good, smooth user experience. If the user is sort of rage clicking on your dropdown, it takes a minute and a second and a half, they're going to say goodbye. So clearly, that'll increase your conversions. And now that Google has become more an advocate about it, and it's become more and more important, clearly. But we're not e-commerce, but I'm sure e-commerce guys can tell you. Even Google itself has a bunch of, on their blog, they have a bunch of real-world examples of by improving your performance, X amount of dollars was improved. And then Sergey, I think his first link, WPO stats, had like real values.
Yeah, WPO stats was a good place. Well, by the way, this is.
Anybody else have questions?
So for the example you had where you went from like 30 to 13, was that because it kicked the process off to the event loop and wasn't blocking? Is that how that performance happened?
Correct.
So I guess the question is, can you talk more about how the event loop helps with performance for INP?
Okay, so if I remember your question, how did that improve at something, right? So I preface that slide with the paint is the main thing. So if you can get that paint as early as possible, your INP number will be good. So if that 30 or 40 milliseconds of execution was happening during the interaction, between the interaction and the paint, there's your INP, right? I should say, but that particular example that's a lab, sort of a lab example. We knew exactly when the event was happening, and we knew exactly how to measure it. A lot of INP is you don't know when it's going to happen. The user is unpredictable. They can be clicking anywhere at any point, and Google's measuring everything. This is real world. So how do you take advantage of that? The truth is, you can't really. You have to optimize every part of your page. That's what they're talking about. Break your libraries up, making it into small, discrete parts, so the browser has time to interact and respond to those interactions. But that particular example is we took that handler, put it, I think, in a set timeout, let it run right after that event, and then the paint happened as soon as because the event loop finished, off to the next loop. Make sense?
Is it fair to say that kicking things to the event loop can help with INP?
That's the recommended practice.
All right.
So you
Those are long tasks.
Yeah, so the idea is you want to break up those long tasks. So that's why Russ, when you talked about the performance tab, when you do your first analysis, you see 80 long running tasks. You want to break those up as much as you can. Because at any point, the user could be clicking, and then there's your IP. Any other questions?
Kind of to that point, how do you discover more INP issues on a page? As you're just, you do a recording, you kind of click around a bit. Like, how do you really make sure you're getting all those potential sources?
Yeah, so, so your observation tools are important, right? So your real user monitoring tools are key. If you're public facing, so that is like Google's indexing and recording and so on, then obviously you'll have stats there about what URLs are a problem. Internally, otherwise you would have to leverage a run tool. The Core Web Vitals plugin's great too, so you could always, it works great. You load it, start clicking around, and you'll find out.
Browser plugin?
Chrome, yes. Maybe other browsers, I don't know, but yeah.
So a good example of introducing INP into your process. Let's say you're implementing a new widget, right? And that widget has an autocomplete feature, right? So before releasing it, you would have it in your pipeline. You would test that rigorously for interaction. So there, for sure, you would know.
Well, I think if you come over here,
okay. So how would you do other interactions? First, you use intuition. Our sites are particularly, you see it and you consume the content, click a link, and But if you have an app that has this particular user interaction, that's key. Test those interactions. Make sure that those are optimized as much as possible. I know frameworks are particularly sensitive because there's a whole hydration phase, and that takes time, right? So you want to minimize as much as possible. Maybe hydrate it incrementally, what we need, but then again, not when the user clicks outside that click. So just, I would say, use the same ideas. How do I make these things asynchronous? And then, sort of like, makes sense.
Did you want to add anything, Ty? Okay, all right. Yeah, we had two here. Yeah. Do we know what's...
I can't do anything about it. I can't do anything about it.
I mean, I can just talk
okay,
about
yeah,
it.
we'll just
project. Yeah. So the solutions you suggested so far seem pretty framework agnostic, but can you speak to how choice of front-end framework or even meta framework like Next.js, et cetera, might have some impacts on INP, or is it not really worth worrying about?
I would say internally we don't use those frameworks to speak too much about it, because I can't give you a direct answer. But common sense would tell you server-side render as much as you can, right? Avoid as much front-end processing as much as possible. Like we talked before, hydration, right? You want to minimize that. Try to get everything server-side, but that's different, right? If it takes too long, the server pays, and, so that's your balance. So that's all I can say about that.
The whole kind of what the shadow DOM concept of frameworks, that's going to be interesting for those folks working with those, which is a lot of the industry, because there is all this complex computing happening for to show something that in some cases literally CSS can do at this point. Like CSS is very powerful, and people are not only using JavaScript to show an item menu, but then using a framework, which is just bonkers. So being selective is pretty key. Jeff,
Yeah, no, I wanted to add, I mean, I think you want to be as static as possible, right?
Oh, yeah.
Like, yeah, I wanted to jump in with like, because I think even Sergey and I, we talked about like, some people are just like throwing HTML CSS now and like,
Yeah,
Sure.
totally.
No, I'm not on the team. I wanted to add, yes, definitely check out your framework, because it's very possible that it's very framework that you think optimized your experience, actually the one responsible.
causes more of a delay.
No names mentioned.
Yes, yeah.
I have a question about observability. I think you showed us a screenshot of it too, based on Elastic. And I think you said you only use it for non-production. If that's the case, ask why, and secondly, what's the cost of doing this in production?
Yeah, it's we're quite likely to put it in production soon. It's actually fairly reasonable.
I assume maybe it's too expensive to actually do it live, or?
No, actually, we can do a pretty high sample rate too. It's a good, very reasonable cost. So,
thank you.
And I can add that all that data that Russ mentioned with Web Vitals library, JavaScript library that CatchPoint uses, it's actually Google's library, so you can report all those metrics to your own real user measurement solution that you run or your vendor runs. The challenge is that there is a lot of attribution data. I don't think you asked how SpeedCurve does it. I did not check that out, but this is the biggest challenge. How do you then visualize? In the past we had one number, one FID per page. Now you have so much data about what happened on the page. How do you make sense out of it? You have more data. It doesn't necessarily that you have a lot of information out of it. You know, there's a difference between having data and making knowledge out of it. So sorry for taking
you're hitting on the head. I mean, we've introduced attribution data in our own way, and it's hard to aggregate it because there's so many different ways that people track on the page. So you can't say this particular unit is a problem. And so they're just clicking on text. There's no link, there's nothing there. Why is that a problem? Because there's something else running in the background that at the exact same time the user was clicking was causing a drive spike. So that's the unpredictability of it. That we really not diverse yet, but we do our best.
And actually, I want to predict that a lot of observability tools will have to change in the future as LCP, CLS, and now INP produce so much more attribution than all the metrics. So attribution now becomes part of RUM, like full-on citizen, and not everyone is ready. Definitely not many vendors are ready. There is a little bit of successful implementation for LCP and CLS, but for INP, we yet to see how to visualize it. But at Etsy, when I was on the team, we kept it. We kept a lot of this data, and then used it for deep dives, right? So you had to use the queries of the world and had to look into your data. You couldn't really aggregate attribution, but you could research where the problems come from. And it is, as Russ pointed out, like DevTools performance panel needs to be a developer tool now, and BigQuery should be a developer tool.
Yeah. Any more questions? Yeah. How many more?
I have a quick question.
Great.
Yeah. So it's actually a question to how. Like I did work with some automation tools in the past to write performance tests, right? For basically the inside like your Jest or whatever other tools. Is there anything special you need to do to monitor networking, to measure time properly, and synchronicity in those frameworks? Do you have any pointers at where to start?
Actually, we have these tools to monitor the network requests and the page state in the automation frameworks. For example, the Selenium. So when it comes to INP optimization, we can just using this provided API to start tracking all the requests and the states to make sure the automation task is synced with the INP changes.
Thank you. Thank you. Do we have any more questions? Okay, one here and one there. And
yeah. So, do you have any kind of like hail holy grail metric that you want to target. Like I know, for example, like a normal screen refreshes at 16 milliseconds per frame, and with the advent of higher refresh rate monitors, is that holy grail kind of change? Because I just think of that because of your example when you had the reduction from 30 milliseconds to 16 milliseconds.
I'll answer that. You want to answer that? We discovered, or sort of, the minimum we have to bring it down to was 8 milliseconds. So that's your baseline. Anything over that is where you want to work. So I guess that's as much as I can say about that. So you can't go under 8. There's just, you have a simple event handler. You're clicking, and it makes a response, 8 milliseconds. And that's on desktop, so mobile will probably be.
Yeah, try to think of kind of animation, like how many frames per second are acceptable to the eye. So that's a good place to start, because that's when people are going to start. That's one. And then two, think of it as, so like an optimization from 30 milliseconds to 10 might sound bonkers, like to people. But remember, you only have 200. And that, and if you've got some ad running or whatever, so we think of it in terms of budgets, right? Like, okay, we want this interaction to be here. We want this main thread processing time to be here. And so it's kind of, you're looking at holistically on the entire application. And again, it really helps the more you consistently create your pages, because then the more you and your developers will start to memorize what's in that. So people will know, oh yeah, that's the GPT.js run, which is part of Google's ad stack. So, so you get to know that after a while, which, sounds daunting, but after a while, actually, it's great, because you're like, I know everything about what's running on this page. And then you kind of know what are good targets for everything and kind of what tends to conflict. So the knowledge will build up over time.
We had another question over here. No, good. Okay, and the team will be here afterwards. You can ask them as well. Thank you very much.